Okay, so in the last video we ran into a bit of a problem. Our psi function got stuck at zeta naught. So no matter what we plug into here, if it's zeta naught or bigger, it's still just going to equal zeta naught. So let's say we try to plug in zeta naught plus 1, for instance. We still just get zeta naught. Because in order to create ordinals, remember, we have to have something to plug into here in the first place. And we're limited to a finite construction of epsilons. So we can never get to that point where we create zeta naught. Now this is when capital omega comes in handy. Because we define this as a very large ordinal, we know it's at least as big as zeta naught. So if we plug this into our function, we also just get zeta naught. So what we've done essentially is take a poorly defined large ordinal and then collapse it down to a well-defined ordinal. Hence the name collapsing function. So how does this get us further? Well, basically because capital omega is contained within set S, we're allowed to plop this down in here and get zeta naught. So now we can move on to the next set C, which would be C zeta naught plus 1. And this would be everything contained within C zeta naught, which would be everything up until zeta naught, as well as zeta naught itself, because we've just constructed it here. So now we can have things like zeta naught plus 1, zeta naught times 2, zeta naught to the zeta naught, etc., with finite constructions. So now we ask, what's the smallest ordinal not contained within this set here? Well, this would be, as per usual, just an infinite tower of our largest ordinal here, which in this case is zeta naught. Blah, blah, blah. And this is equivalent to epsilon zeta naught plus 1. Now this might not be entirely clear, so I went and did a little arithmetic here for you guys. So we start with epsilon zeta naught plus 1 and take an arbitrary element from the fundamental sequence, in this case the third element, which is omega to the omega to the omega to the epsilon zeta naught plus 1. Now this collapses because this is all by itself here into just zeta naught. We can drag this 1 down here into a times omega on this line, and then this is all by itself and it collapses into zeta naught. We do a little bit of arithmetic here, and then we do our little trick where we do 1 plus omega. Because if you write it like this on the left-hand side here, this is still just equal to omega. Then we do some more arithmetic tricks here, and we end up with zeta naught to the omega. So we can extrapolate and say that if we had an infinite tower of omegas, it would equate to an infinite tower of zeta naughts. And this works with any ordinal that's as big or bigger than zeta naught. We can put it in an infinite tower and write it as epsilon of that ordinal plus 1. And this one is also known as the first epsilon after zeta naught. So now we can move on. Or before we do it, let's write this down. So this inaccessible point is defined by our next psi function, which in this case would be 1 plus this. So we have capital omega plus 1 is equal this first epsilon number after zeta naught. There we go. So now we can move on to psi capital omega plus 2. So we can imagine taking this construction now and plugging it into the next set, and the first inaccessible point now would be an infinite tower of this, which is equivalent to the second epsilon number after zeta naught, or epsilon zeta naught plus 2. And in general, we can say that psi capital omega plus a is equal to the 8th epsilon number after zeta naught. But we have to be careful once again, because this function is going to get stuck again. And this time, it gets stuck at zeta 1. So you can imagine the same kind of thing. So before, when we plugged in epsilon naught, epsilon, epsilon naught, epsilon, epsilon, epsilon naught into the function, we got bigger and bigger epsilons, but we ran into problems when we tried to get an infinite nesting of epsilons. But now we have zeta naught to work with. So we can plug in things like epsilon zeta naught plus 1, epsilon, epsilon, zeta naught plus 1, blah, 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 to an arbitrary number of nested epsilons. But we run into problems when we try to get an infinite number of nested epsilons, and this time with the zeta naught plus 1 at the bottom. And this is equivalent to zeta 1. So you could think of the limit of this as being just zeta 1. So we can almost get there, but not quite. So now we use our capital omega again to get us out of this point and unstick the function once again. So we can have psi capital omega plus capital omega is still just equal to zeta 1. And this truncates to psi capital omega times 2. And now we can move on. We can now that we have zeta 1 to work with, we can move on to our next psi function, which is capital omega times 2 plus 1. And that's the first epsilon number after zeta 1 this time. And in general, we can say psi capital omega times 2 plus a is equal to the 8th epsilon number after zeta 1. And this time, the function gets stuck at zeta 2, because you can imagine now making arbitrary constructions of epsilons, blah, 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 now with zeta 1 plus 1 at the bottom, which is defined as zeta 2. So we can almost get to zeta 2, but not quite. And once again, we just plug in another capital omega to get out of this trap here. So we end up with psi, capital omega times 3 this time, is equal to zeta 2. And we can say in general that psi, capital omega times a, is equal to zeta a minus 1. So you can imagine us keeping on adding capital omegas into here to continually unstick the function again and again and again and again and again. And it's going to reach a point actually where this itself gets stuck. But I'm going to leave that for the next video.